In this video, we are going to be reviewing factoring. The first method of factoring we have is the greatest common factor. And sometimes in math, knowing a definition is not very helpful. But with the greatest common factor, the definition literally tells you exactly what to do. So to find the greatest common factor, you are looking for the largest number, or the biggest number, and the least power of x. So when you're looking to find a greatest common factor, you want to figure out the biggest number that goes into everything and the smallest power of x that you see, which may not be an x at all. So looking at this first one, we have 4x cubed minus 6x squared plus 8x. First thing I'm thinking about is what is the biggest number that goes into 4, 6, and 8? Well, I could try with 4. 4 goes into 4. 4 does not go into 6, but it does go into 8. So 4 doesn't go into all three because it doesn't go into 6. So I'm going to go even smaller than 4 then. And think about what other numbers go into 4 would be 2. 2 goes into 4, 2 goes into 6, and 2 goes into 8. So my biggest number that goes into all three of those numbers is going to be 2. And then I'm just looking for the least power of x. So between x cubed, x squared, and x, the least power of x is just a regular x. So there's my greatest common factor. Biggest number, least power of x, and then we're just multiplying back to get to where we started. So I'm thinking about 2x times what gives me 4x cubed. Well, 2 times 2 gives me 4, and then when you multiply bases, you add exponents. So if I want to add up to be the power 3, I need to take this 2x, which is really to the first, normally we don't write the first power, and multiply it by 2x squared. Because we have 2 times 2 is 4, and then x to the first times x squared is going to give us 1 plus 2, we'll get x to the 3, just like what we like. So we got that first piece. Next, I want to multiply 2 times a negative number to make it negative 6. So 2 times negative 3 will give me negative 6. And x times x will give me that x squared. Because we'll have 1 plus 1 in our powers gives us 2. When you multiply bases, you add exponents. Last term, we want to multiply to be a positive 8x. So 2x times 4 will give me 8x. So you can double check by distributing to make sure you get all three terms back, and we will on that one. So you're pulling out the biggest number and least power of x, and you can try that with any number of terms. So here we had something that was 3 terms to start with, but even if it had 4 terms or 2 terms, we could always pull out a greatest common factor, regardless of how many terms are in there. Whereas the next one, difference of squares, is only for binomials. It has to only have 2 terms, or else we can't even use this method. So difference of squares means you have a first number and a second number that are squared, and it's a difference. So they have to be subtracted, right? A sum would mean addition, and a difference means subtraction. So you're thinking about what's getting squared. Well, for the first one, x is getting squared, minus the second term is a getting squared. So you have a difference, subtraction of 2 square numbers, factors to be x plus a times x minus a. The first number that's getting squared plus the second number that's getting squared times the first number minus the second number getting squared. So for instance, this is a binomial, something with 2 terms, x squared minus 81. It is a difference because there is subtraction, so that's good. And we want to see what's getting squared. Well, for the first term, x is getting squared, minus for the second term, what gets squared to be 81 would be 9. So when we factor this, it's going to factor to be x plus 9, x minus 9. And we could always multiply this out by distributing or using FOILing, and we would get back to that x squared minus 81. So we know we factored correctly. So anytime you have a binomial, 2 terms, you can think about if it's a difference of squares or not. It's only going to work if you have subtraction and 2 square numbers. The last method is reverse FOILing, which is specific to trinomials. I'm only going to try this on something with 3 terms. So greatest common factor can work for any number of terms. Difference of squares is only for binomials, 2 terms, and reverse FOILing is only for trinomials, 3 terms. So when you do reverse FOILing, you want to multiply to be which one? Do you remember from algebra? You have x squared plus ax plus b. You multiply to be that last term. So you multiply to be b in this case. And add to be a. All right, so we're thinking of numbers that multiply to be the last term, but add up to be that coefficient of the second term. So looking below there, you have x squared minus 2x minus 15. Notice if I try a greatest common factor, there's not a big number that goes into 1, -2, and -15. It would just be 1. We only pull out a 1, which isn't helpful. And then there's not a least power of x. So we can't factor using the greatest common factor first. We would just jump to reverse FOILing. So for this, we want to multiply to be -15 and add up to be -2. Well, multiplying to be -15 is super helpful because there's only one way to multiply to be a negative. You have to have a positive times a negative, right? If you had 2 positives, that would multiply to be a positive, or 2 negatives. A negative times a negative would also be positive. So to multiply to be a -15, I must have a positive times a negative. And now I want to think of factors of 15 that differ by 2. So 15 and 1 wouldn't work because the difference would be 14. 3 and 5 would work though, because 5 and 3 differ by 2. So we want to make sure it adds up to a negative, which tells me the bigger number is going to be the negative one. So you have -5 plus 3 is -2, and 3 times -5 gives us that -15. So multiplying to be -15, adding up to be -2. So there's the 3 methods. You can try these next ones and see if you know how to factor any of them. If not, pop on the next video and I'll explain how to do each of those.